Alright, good afternoon everyone. Thank you very much for taking the time to come over to practice on the AMC competition past year papers. My name is Teacher Chi Yew from Think Academy, and I sincerely thank you for taking the time to watch this video. Now in this video over here, we are going to go through some of the much more difficult questions in the 2018 Upper Primary AMC exam paper. So in this case over here, there are going to be questions 26 to question 30. But nevertheless, if you guys have any questions from question 1 to question 25, you guys can feel free to reach out to me via WhatsApp as well, and I'll be available to answer your questions. Now without further ado, let us begin on question 26. Now, in the algorithm below, the letters A, B, and C represent different digits from 0 to 9. What is the 3-digit number A, B, C? Now, so every time when students would like to answer questions, it's always very important to always keep in mind to highlight the important keywords in the question. Now in this case over here, what are some important keywords over here? Now in this case, the letters A, B, and C represent different digits, alright, all the way from 0 to 9. And what's our end goal? Our end goal is trying to find the 3-digit number A, B, C. Alright, so we are going to find out what is A, B, and C separately, and we are going to combine all of them together. Now, so in this case over here, let me write another picture over here to try and illustrate this better using inference. So we have the same structure over here, but I can edit this particular picture. Now, so let's start off with the most common number here. In this case, let's take a look at the tens place. Well, the tens place over here, we notice that in the thousands place, there must be a carry forward of 1, because in the thousands place, the final value is 2, and we only have a 1 there. So in this case over here, we definitely must have a carry forward of 1. And we really would like to make A, and hence this gives us the idea to try and make A as large as possible. Now in this case over here, what's the largest possible number that we can actually have? In this case, it will be A equal to 9. So we can actually try out A equal to 9 first, and in hopes that we can actually carry forward a 1 over in this case. So let's try it out. Then we are going to remove the A's here, and we are going to replace them with 9's. Alright, great. What's next? Now, in this case over here, we notice that in the ones place, there must be a carry forward 1, because 9 to 8, there must be an additional value such that it carries 1 forward to the tens place. So we are assured to have a carry forward 1 over here. Now, what does that mean? We have 1 plus 9 equal to 10, and we require a 1 at the tens place. So it makes sense for us to make a smart guess that infer out that B must be equal to 1 in this case. Alright, so we have a 1 and a 1 over here. Alright, great. So what's next? Our final value in this case. Now our final value will be pretty straightforward. If we look at our ones place over here, we can see that we have 9 plus 1 plus C plus 0 ends with an 8. Now, what number will actually makes the most sense over here? Well, in this case, it will be C equal to 8, because 9 plus 1 plus 8 will just be 18. It carries forward over a 1, and it adds up to 8 in the ones place. Hence, we have obtained our 3 values over here already. But don't forget, what are we looking out for? We are looking out for the 3-digit number A, B, C. So our final answer is going to be A, B, C equal to 9, 1, 8. And that is our final answer for question 26. Alright, so I hope everyone is able to understand this crypto-arithmetic puzzle. And without further ado, let us move on to question 27. Now, question 27 is really simple. Using only digits 0, 1, and 2, right? This cube has a different number on each face. Now the numbers on each pair of opposite bases add to the same total. Now what are we looking for? We are looking for the largest total in this case. So we are going to sum up the three pairs of sides of the particular dice. So let's take a look at what possible sides are there over here. Well, we have the top view. We also have the front view. We also have the side view. What's the opposite of the top view? Well, the opposite of the top view is simply the bottom view. The opposite of the front view is simply the back view. And the opposite of the side view is simply the other side view. Now in this case over here, you must remember that all the numbers with the sum of the pairs of sides, opposite sides, are going to form up the same number. That is a very crucial hint that we require. Now let's take a look. Let's start off with the hundreds place, alright? Now we notice that in the hundreds place, we have 2, we have 1, we have 2 as well. Well, it can't make sense for us. It is not possible. We notice that it is not possible for the hundreds place to start with a 4 because we can't have 2 plus 2 in this case. But what we can certainly have is a 2 plus 1. Now, hopefully, many of you guys can see the pattern now. You got 3. So in this case over here, what we casually did was take the 2 and the 1 that appeared on the hundreds place of the dice, in this case, and we just add them up together. Why does it work? Because 2 can pair up with 1 to form a 3, and 1 can pair up with 2 in our form of 3. Now, we can kind of get this idea going in the same sense, right? Let's take a look at the tens place. Well, the tens place over here, we have 2 and 0. Well, following the same idea, the tens place is just going to be 2 plus 0, which is equal to 2. And what about the ones place? Well, the ones place, we have 0 and 1. And hence, the ones place is just going to be 0 plus 1 equal to 1. So, the largest total that this dice can actually have is going to just be 321 for each pair, each sum of the opposite pairs. Right, so this one will rely a little bit on geometrical thinking and be able to infer from the 3 sides of the particular dice. Right, now without further ado, let's move on to the next question. Now, I wrote counting numbers joined together in this fashion. So, some of you guys might be asking, what are counting numbers? Well, counting numbers are simply just natural numbers, which begin with a 1, 2, 3, 4, and so on and so forth. Alright, so in this case, we can see that in this example, we have 1 all the way to 9 joined together. We have 10, 11, 12, 13, 14 joined in this fashion, and so on and so forth. Right, so it's going to be a continuous number. Now, what's the question over here? Which of the counting numbers was I writing when the 100th zero was written? Now, so in this case over here, what's the 100th zero? Now, in this case, let's take a look at an example. In this example over here, in this case over here, this one is the first 0 that we actually saw in this number, and it belongs to the counting number ten, because the 0 belongs to the 10. So what we are looking for is the counting number in which the 100th zero belongs to. So in this case over here, it looks a little bit difficult at first, but with a little bit of critical thinking, we will be able to solve for the numbers. Now in this case over here, let's take a look and try to infer what is going on. Well, we have 1-digit numbers, in this case, 1 all the way to 9. We also have 2-digit numbers, which is 10 to 99. We also have 3-digit numbers from 100 to 999. it makes sense for us to break them out into different parts. In this case, 1-digit numbers, 2-digit numbers, and 3-digit numbers. And we will try to calculate the number of zeros between all of them, try notice a pattern, and then we will be able to apply this particular pattern over and over again. So what do I mean by that? Now let's take a look at the first 9 digits. Alright, how many zeros are there in the first 9 digits? Right, we have 0 zeros, right? For the simple reason being, 1 to 9 doesn't consist of any zeros. Now let us move on. What about 10 to 99? In this case, the 2-digit numbers. Well, for 10 to 99, the number of zeros that we have over here, in this case, would belong to 10, 20, 30, 40, all the way to 90. In this case, it is pretty clear that we actually have 9 zeros. Now, what's next? Now we'll move on to our 3-digit numbers. Alright, we are progressing well. We are going to hit the 100 zero really soon. Now what about the 100 zero? 100 zero is going to be a little bit complicated. So we are not going to calculate all the way from 100 to 199. To 999. But rather, we are going to calculate from 100 all the way to 199 instead. Because the number of zeros in 100 to 199 is going to be the same as the number of zeros in 200 to 299, 300 to 399, and so on and so forth. So it makes much more sense that we do that instead. So how are we going to do it? Well, let us break down the problem into these kind of problems again. Let us start off with 100 itself. Now in this case, at the bottom left corner, let us write out. For 100 itself, we actually have 2 zeros. Alright? And then let's move on. What about 101 to 109? Well, 101, 102, 103, all the way to 109, we actually have 9 zeros. Now let's move on. In this case, we have 110 all the way to 199. So in this case, we have 110, 120, 130, 140, all the way to 190. They are going to give us 9 zeros as well. So what do we see over here? From 100 all the way to 199, we have 2 plus 9 plus 9, which is just equal to 20 zeros. So there is 20 zeros in 100 to 199. So this one will also imply that there are 20 zeros from 200 to 299, 20 zeros from 300 to 399, and so on and so forth. Now let's try to hit as close to 100 as much as possible without going over. In this case, if it's a multiple of 20 and we already have 9 zeros, it will make sense for us to do 100 all the way to 499. Because this one will consist of 80 zeros. And that will give us a grand total of 89 zeros. And after that, it will all be simple listing in order to get the final number. So in this case over here, we can start off by writing out all the other possibilities after 499 and count the number of zeros. We need 11 more zeros. 500, 2 zeros. 501, 1 0. 502, 1 0 again. 3, 1 0. 5, 1 0. And we realize that the 100th zero will belong to the 11th zero over here. And it is going to be at 509. And hence, the final answer is going to be 509. But of course, there's a little bit slightly faster way to do this as well. We can actually consider just 500 itself. And then we just need 9 more zeros. 500 has 2 zeros. So we just need 9 more zeros. And 501 to 509, just nice, gives us 9 zeros. And hence 509 is the answer. But of course, if we have a little bit of zeros left, it wouldn't hurt if we actually try to list out all the possible numbers. It will also work as well, and we'll get the same answer. So hopefully this one has challenged you a little bit, and I hope that you guys have learned some strategies on how to solve these kind of problems with regards to numbers being joined together and counting the position, that counting a number in which the particular zero is in. Right, without further ado, let us move on to the next question. Now for question 29, we have Jen and Jill are both on a circular track. So in this case, Jill runs at a steady pace. Alright, so she's running at a very constant speed, completing each circuit in 72 seconds. What about Jen? Jen walks at a steady pace in the opposite direction and meets Jill every 56 seconds. How long does it take for Jen to walk each circuit? So what we are looking at is a circular track. And hence, in order to try to better visualize the problem, it will make sense for us to try and draw out a small circle. You'll better understand what is going on over here. So maybe we can have Jill running in the anti-clockwise direction, and we have Jen walking in the clockwise direction. So Jill is going to complete the circuit in 72 seconds. She is going to meet Jen at every 56 seconds. So let's take a look at the 56 second itself. How much of the track would Jill complete? So maybe they are going to meet around here. So this is going to be their meeting point. Probably, because Jill is probably going to run faster than Jen. So how much of the circular track has Jill completed? Well, for Jill in this case, we can see that it will just be 56 over 72. For a simple reason being, she runs at a steady pace. She completes each circuit in 72 seconds. And only 56 seconds has elapsed. So in this case over here, she'll have ran 7 out of 9 of the track. What about Jen? Well, naturally, Jen will actually have 1 minus 7 over 9, which is 2 over 9 of the track. So this gives us a little idea about ratio. There's a little bit of ratio going on over here. Every particular time, every 56 seconds in fact, Jill is to Jen is going to be 7 over 9 is to 2 over 9 of the particular track. And if we are going to multiply both sides by 9, it's going to be 7 over 2. Now what does this mean? This means that when Jill runs and completes 7 rounds, Jen has just completed walking 2 rounds. And what would that mean? That would mean that the time taken for Jill for 7 rounds would simply just be 72 times 7, which is equal to 504. And this is equal to the time taken by Jen to run 2 rounds. So in order to find out how long does it take for Jen to walk each circuit, all we need to do is to take 504 divided by 2, and we'll get our final answer of 252. So I hope indeed through this question you'll be able to better appreciate the concept of speed and ratio together. On top of that, you are also able to use ratios and simplify them in order to get a better understanding of how much units of a particular track that has been covered by a particular person. Alright, so without further ado, let me move on to the last question for the day in this video. So let's take a look at this question over here. The answer to a cross number puzzle clue is a whole number. Alright, so all these numbers are actually whole numbers. A fragment of such a puzzle is shown. We have a few clues that we are looking at. Now, so 1 across is actually the square of a whole number. And 6 across is half of 1 across. Alright, so make sure you keep in mind there's a mistake in this paper. 1 across is square of a whole number as per the Chinese translation. And 6 across is half of 1 across. Alright, what about down? 1 down itself is twice of 2 down. And 2 down is a multiple of 9. So what are we looking out for? We are looking out for 2 down. Now in this case over here, 2 down is just going to be this particular column because it starts with a 2. Alright, so without further ado, let's try and infer and see what can we do in this question over here. Well, the first thing that I would like to infer is to look at 1 down. We notice that 1 down itself is a 4-digit number. And it's twice of 2 down. Alright, so in this case over here, 1 down is a 4-digit, and 2 down is a 3-digit. So what is a possible candidate for this number over here? In this case, it must be 1, right? What's the greatest possible number of 2 down? Greatest possible value of 2 down. In this case, theoretically, it will be 999. And greatest number in this case is 999. And since 1 down is twice of 2 down, the greatest of 1 down must be equal to 999 times 2, which is equal to 1998. And hence, we can immediately infer that this number must start with 1. That is the main idea on how do we go about solving this question. Now, what's next? Let's take a look at 1 across now. 1 across is a square of a whole number. Well, in this case over here, we can narrow ourselves down to 4 different possibilities according to our multiplication table. Now, based on our multiplication table, we have 11 square, which is 121, 12 square equal 144, 13 square equal to 169, and 14 square equal to 196. Right. So in this case over here, we can narrow our choices down because 10 square, or maybe we can actually have 10 square, which is equal to 100 as well. Now, in this case over here, what we notice in this case over here is impossible for 10 square to occur because twice of something that starts off with a 0 over here, suppose it's 100, twice of 2 down is going to be at most a 3-digit number. So we are going to remove 100 from our answer. Now, let's take a look at the next example over here. Let's take a look at 6 across now. 6 across itself is just half of 1 across. What does that mean? And because the answer to cross number puzzle clue is a whole number, we can't accept any decimals. So in this case over here, we can immediately strike out 2 numbers that do not match this criteria. In this case, will be 11 square and 13 square. Because both of them are odd numbers, when we divide them by 2, we will not get whole numbers back. In this case, now we are left with just 12 squared. We are also left with just 14 squared as well. Now let us try and do 12 squared, for example. So maybe it's 12 squared. And we notice it looks alright, but until it starts to contradict something. Remember, 1 down is twice of 2 down. What would be the greatest possible value of 2 down in this case when 1 across is just 144? In this case, the greatest possible value will be 499. But 499 times 2 will give us 109, will just give us 998, which is a 3-digit number. But 1 down is a 4-digit number. So in this case, it's impossible for us to actually have 12 squared 144 in 1 across. So this is wrong. And the true one. And hence, we can remove 12 squared from our answers over here. And hence, we are just left with 196, which is 14 squared. Now, so let's put that in. That is going to be very likely the correct answer. Now what's next? In this case, it becomes really easy to solve now. 6 across is half of 1 across. In this case, we just take 196 divided by 2, and we are going to obtain a value of 98. And then afterwards, we notice that 2 down itself is a multiple of 9. So what does that mean? It means that it is divisible by 9. Alright, and one very important property about divisibility by 9 is the sum of all the digits must be divisible by 9. So in this case over here, we have 6 plus 9 already. 6 plus 9 will be equal to 15. How do we make it divisible by 9? How do we add the last digit such that it's divisible by 9? Well, 18 is the next number in line such that when we add them up, we'll get 18. In this case, 18 divided by 9 will give us 2, and hence 18 is divisible by 9. So in this case, it makes sense for us to add a 3 to get 18. And hence we conclude that this number must be a 3. And therefore, we have actually obtained our solution. Alright, it doesn't really matter whether we try to solve for one down, because our whole goal is to try and solve for 2 down, even though 1 down is just 693 times 2. Right, and hence our final answer is just going to be 693. Alright, so we have come to the end of our solutions go through for the AMC Upper Primary 2018 past year paper. Really appreciate your time. But as usual, if you guys have any questions of any kind, feel free to WhatsApp me, Teacher Chi Yew, and I will get back to you on questions such as from question 1 all the way to question 25. Alright, so without further ado, let us end the video session over here, and keep a lookout for the next paper and the next video recording. Right, with that, thank you very much, and I will see all of you again.